Alright, now that we've solved that triangle, we can move on to this next one. And taking a look at it, we see that we have two sides and an angle, but the angle is not the angle that's opposite either of those sides. It's the included angle. So we're going to use the law of cosines to help solve this triangle. So we'll set c squared equals a squared, or 144, plus b squared, or 324, minus 2 times 12 times 18. That's just 2 times these other two angles, or these other two sides, times the cosine of the included angle. And we'll go ahead and move the square root, or the square, to the other side. So we'll take the square root of both sides, and we get the square root of 468 minus 432 times cosine of that angle. And we want to wait as long as possible to do this multiplication, because we're going to have to round. So we're going to wait until we can do that under the square root. That's why we didn't do that from this step to this step. Okay, and then we can see that c equals, if we punch this square root into a calculator, we get 13.17. Alright, and now we have two sides, an angle and the side opposite that angle, so we can now use the law of sines to finish out this triangle to find those two missing angles that are opposite side A and side B. So we'll find angle A first. Sine A over 12 equals sine 47 over 13.17. We multiply both sides by 12. Sine A equals 12 sine 47 over 13.17. Sine A is going to equal, put that into a calculator, 0.67. And so, since we know that with the law of cosines, we only have one possible solution, because we already know for a fact that the length of the three sides, so no side is going to be able to have two lengths. So we only get one solution, so we don't have to worry about that. And the solution for angle A, if we just use the inverse sign, see that A equals 41.79. Now for angle B, we don't have to use the law of sines since we have two angles. We can just set the equal 180 minus 47 minus 41.79. And that equals 91.21. Alright. Now we can solve one more triangle when we're given sides and angles, and then we'll get on to applications of the law of cosines, using that in real life examples. So we have an angle and two sides, but this is the included angle of those sides, so we can't use the law of sines, we have to use the law of cosine again. So b squared equals a squared, or 625, plus c squared, or 1600, minus 2a times c times cosine of the included angle. Okay, we're going to go ahead and take the square root of both sides. So b equals the square root of 2,225 minus 2,000 times cosine 32. Put that into a calculator, and we get b equals about 23. Alright, and now, so we have angle B, side B, and sides A and C, so we need angles A and C. So we'll go for angle A, sine A over 25 equals sine 32 over 23. So sine A over A equals sine B over B. Multiply both sides by 25, and we'll get sine A isolated equals 25 sine 32 over 23. Put that in a calculator. Sine A equals 0.576. Alright, and then use the inverse sign to get A equals 35.17. And finding B is same as we did up here. To find angle B, we'll just do 180 minus the angles that we know of 32 and 35.17, which equals 112.83. And there's the solution to that triangle. And next we will work on these application problems.